The Firmament, Finding the Truth. Please pause and read. At this point, we've talked about multiple proofs of the firmament, but the one that puts the nail in the coffin are rainbows, and even more mind-blowing are double rainbows and how they look in Alaska versus Antarctica. But before we get into that, let's talk about how a single rainbow works. At some point, you've probably asked yourself, why is a rainbow in the shape of a dome, or how does it get its shape? Science will tell you that a rainbow is caused by sunlight and atmospheric conditions. As light enters a water droplet, slows down and bends as it goes from air to denser water. The light reflects off the inside of a droplet, separating into its component wavelength or colors. When light exits the droplet, it makes a rainbow. Now, some of this is true, except the water droplets are only there to work as a screen to capture what's being projected. The first thing to understand is that light has to go through a glass prism, and whenever it goes through that glass prism, it leaves and the light refracts and it goes into all those colors you see in the rainbow. And a rainbow always takes the shape of its glass prism. And you can test this out at home. Get a glass, fill it up with water, and then use a light source to shine it through the glass of water and see what happens. And what you'll find is the shape of the rainbow is going to be determined by the glass prism's shape. So using a dome-shaped glass will give you a dome-shaped rainbow. The Word of God says in Job 37:18 that the sky is strong as a molten looking glass, or some versions say a molten mirror. The firmament is the dome-shaped glass prism which gives the rainbow its shape. Now remember, you can't always see a rainbow outside on any given day, but if you get a water hose and turn the mist on, you can see a rainbow because the water acts as a screen. Now let's get deep and talk about the double rainbow. You can see the original rainbow in the sky, a double rainbow right above it, and in the water there's a reflection of the rainbow. Let's talk about the reflection in the water real quick. You can see the colors of the rainbow in the water are inverted. They're upside down compared to the rainbow in the sky, and that's because it's a reflection of the original rainbow. Now for the really cool part that's gonna blow your mind. You see how the double rainbow, which is above the original, how the colors are also inverted and upside down? It's because the original rainbow is being reflected off of the glass prism above it. The rainbow is being reflected off the glass firmament, and that's why the colors on a double rainbow appear to be inverted. Here's a science experiment you can do at home to show you that the double rainbow is being reflected off the glass firmament. Get a piece of paper and draw a rainbow on it. Hold it up to a glass mirror and see how the colors invert when holding it up to the mirror. Just like a double rainbow we see in the sky being reflected off the glass firmament. Now for how rainbows appear different in Alaska versus Antarctica. This photo was taken in Alaska, and you can see a reference to where this is on the map with the red dot and how it's closer to the center of the Earth. Now remember, a dome gets higher up the closer you are to the center of it. But guess what happens when you go further out towards the edge of the Earth? Let's go a little further down in Canada. You can see the rainbow isn't arched quite as high as it was in Alaska. Now when we go to Australia, which is much closer to Antarctica, you can see the rainbow is looking more flat and not as tall as it was in Alaska and Canada. Now if we go all the way out to Antarctica, the rainbow looks like nothing we have ever seen before. It's almost like a pancake. Here's another photo from Antarctica, and it's possible these two photos could have been taken from different locations in Antarctica, but you can compare the height of the rainbows in these different locations and see a clear difference in the height of all of them. So if the firmament is lower near Antarctica, it would make sense as to why the rainbows appear smaller the further you go south. And if the firmament is at its highest point near the center of the Earth, it would make sense as to why rainbows appear the way they do in Alaska with a higher arch. And in the next video, we'll take a deeper look at stars and talk about their distance from Earth, what they could possibly be, and much more in part 13 of The Firmament, Finding the Truth.